the future. Okay, chapter 1 was solving linear systems. I would like to solve this linear system by substitution. What are the steps of substitution? What do I do first?
You're gonna want to substitute the y 6y for x, so you could solve for the one column and find x, and then you could put y. Then you find once you find x, you could put that you plug that in, and you could find what y is. You can
So
solve
the
for
first,
y.
yeah. So the first thing in substitution is you have to isolate a variable because you're going to take one out, like Matthew was saying, and substitute in something else. How do I know which one is the easiest variable to isolate for?
X.
How
There's
did you
no
know that?
coefficient in front of it. There's no number.
Perfect. This x
Because
is
x is by itself. That's why. Well, that yeah, you just circled y.
very good. So x is all by itself and positive. So all I have to do is move the 3y over. What am I doing with this negative 3y then? Guys, the quicker you participate, the quicker done. Thank you, AG. So what's it going in for?
X.
X in the second
No, the
equation. Very good. So X is coming out and its replacement, it's like it's being subbed out of the game and its replacement is going in. So negative 3y is going in. I would love for somebody just to walk me through the basic algebra here then on solving for y, my only remaining variable. Who wants to do that for us?
1, 2, 3. No, 1. Maybe you have to do you have 2 here.
We multiply minus 3y by the 3.
Good. So you're going to distribute this. And AG, keep on going because that'll make this go a lot faster for us. What's next?
Then you minus 9y by 6y.
And that is?
That would be minus 3y.
You're actually 9 in the hole and going 6 more further in the hole.
Okay. So minus 15y.
Good, good, good. All right. Last step here. How do I isolate
You
for
divide
y?
it by 5.
Yeah, so I'm gonna divide by negative 15. Whatever's attached to my variable, I'm gonna divide that off. That will leave me just y because this negative 15 and negative 15 will cancel. It reduces to 1. On your calculators or mental math, what's 5 divided by negative 15?
Negative 0.33 continue.
It is a fraction. And remember, that is a possibility. Point of intersections don't always have to be whole number points. So y is negative 1/3. What am I doing with that negative 1/3?
You're putting it in for y.
Good. Now I'm going to solve for the other variable. So substitute the negative 1/3 into either of these original equations. So Avina, which one is going to be easier, do you think?
Which one is going to be what? Probably the first one, the top one, because it's going to be less, like you'll have to find out less, I guess.
Very good. And we've already isolated this for x, so I can just plug in negative 1/3, my value for y, and immediately I have x. So what's negative 3 times negative 1/3? You guys should have calculators there, so it should be pretty quick here.
1.
Negative 1.
Perfect. And negative times negative actually is going to be a positive 1. Your last step.
Oh, I didn't see the negative.
That's okay. Yeah. The last step for solving for your point of intersection is to write it like a point. So x goes first, y goes second. And this is our final answer here that we're looking for. And remember, how do we make sure that this is correct?
You can plug it back into the original equation and see if it works.
Very good. Plug them back into both original equations and make sure it works. This one would be a little bit easier on the calculator. But if I check this bottom one, 3 times 1 is 3. -6 times -1/3 is actually become +2. If you don't believe me, you'll try that on your calculator. 3 + 2 is 5. It will work in both equations. So please make sure you're using good problem solving. Most of us preferred elimination instead of substitution. So either one is fine on Friday when you're working on your culminating task. You can do substitution or elimination. So don't feel like you have to know both of them. Here's the steps to elimination. Hopefully we remember them. How do I eliminate a variable? Here's my linear system. What will I do?
2y and -2y cancel each other out if you subtract them.
Fantastic, Kira. So Kira was focusing on this variable here. They have the same coefficient, and you want them to have opposite signs. You want to add the opposite. That was kind of our mental note. So add the opposite, meaning opposite signs. A plus and a minus will cancel. Sorry if you can hear my kids in the background. So I'm going to add these. Kira, what will I get when I add them together?
You get 8x = 24, I think.
Yeah, perfect. And then how do I solve for x?
You divide both of them by 8.
Awesome. So that 8 reduces to 1, and what is x?
3.
3. Okay, and then the last step in elimination and substitution are the same. Kira, which these equations do you recommend using in order to find my y value?
The top one.
Yeah, what was your thinking there about using the top one? Because I love it.
It's adding.
Perfect.
It's
One
adding.
of your guys' favorite pastimes to do is just to like drop negative signs. So if you can avoid negative signs, do that. The top one is all positives, and then it's just a matter of being a really good algebra problem solver here. 3 times 3 is 9. How do I isolate for y?
You move the 9 to the other side and do 19 minus 9.
Love it, Kira. And then what's my last step?
Divide it by 2 to get y = 5.
Awesome. And it's a little bit easier to check your work when the answers are whole numbers, but they will not always be whole numbers. But this one can be checked fairly easily. Has anybody done the mental math? Plug them in. Does this work? 3, 5. Does that look good?
Now, make a pattern by writing each animal name. Okay, so you can do how are you going to do L?
Yep.
Yes, thank you, Ian. Both of them work. Fantastic. I'm not going to do another elimination. I just want you guys to tell me, what would you do first if I gave you this linear system and you chose to do elimination? What would you do first? Are any of my coefficients the same?
No, would you multiply like the 3x minus 4y by like -2?
Yeah, that's good. So you could make the x's both 6x, and Kira's even right away making it -6x. Or what would you make the y's?
Okay, I'm done.
You can times each of them by the opposite number to make them both 20.
Fantastic, AG. Good. So you're going to multiply in order to make them have the same coefficient. Now, question, would you want to do this one by substitution?
Oh, I get it now. Do you have to just keep writing it?
You can, but you'd want to do this one by elimination because there's no variables isolated already, so it's easier
Yeah.
to do elimination.
Exactly, Matthew is correct. There's a 6 in front of this x and a 3 and a 5 and a 4. None of them are just a coefficient of 1. So it would be possibly difficult to do by substitution. So this one I would definitely recommend by elimination. I will tell you the one I'm going to give you on Friday can be done either way. So it'll have a variable that can be easily isolated for substitution, or if you want to do elimination, you can also do elimination. So you'll have an option on Friday. Chapter 2, so this is still unit 1, this is still analytic geometry, focused on some formulas: midpoint, distance, and circle. All of these are actually in your review package. So if you go into Edsby and you print this review package, which I would highly recommend printing, and if you have color, do this in color. You have all of your formulas on your first couple of pages. So here's slope, distance, midpoint, circle. Here's the kind of the mental, I guess, brainstorm of how to convert between your different quadratic forms. Here's some formulas, your trigonometry, triangles, sine law, cosine law, and I even included your factoring flow chart. So all of that is going to be there for you to utilize on Friday. So I would strongly suggest print that document so you have all of those formulas. There will be some basic questions on find the midpoint of this line, find the distance of this line. We're going to do circle here in a minute, but you'll want those formulas. This question, you'll have to do this on Friday. We'll have to review. What's a right bisector?
Hold on. See, I just did the arrow.
What does the word right mean in math? It doesn't mean you're
90
correct.
degree angle.
Fantastic. 90-degree angle. And what does it mean to bisect something? It doesn't just mean cut. What does this mean? What does it mean to bisect?
It crosses through the line at a right angle.
Through what point, Zach?
Just make a really long.
Oh, right, right through this the median
Very close, right through the midpoint. Yeah,
midpoint, right?
yeah,
Yeah, that's what I meant.
perfect. So it cuts it into 2 equal portions, or for us, that means it's going to go through the midpoint. So it's going to go through go through the line at a 90-degree angle. And it's going to cut the line into 2 equal portions. This is all we actually need to know when we think about right bisector. It's telling me to look at DF. So that's actually this line right here. I want you guys to do this in a particular order. Right
You can't actually.
first. 90-degree angle
Really bad.
also means the 2 lines will be what? What's another math word we could use? Two lines when they meet at a 90-degree angle will be what to each other?
Two lines that meet at a 90-degree angle.
Yes.
They'll intersect.
But what is another math word to describe those 2 words to each other?
Perpendicular.
Perpendicular. Thank you, Ian. Because that's what we really need to know here. It's perpendicular. Can't squeeze that in there. Okay. Perpendicular, which you guys learned last year in grade 9, meant that they have negative reciprocal slopes. So negative reciprocal slopes. What is the slope of line DF, or how am I going to find that?
See, he didn't bring it to the top. Mini max.
Well, here's your slope formula.
Mini max.
How am I going to find the slope of DF?
You can just plug in both the points.
Perfect. Ian, I'm going to label these D as 1 and F as 2. Can you just walk me through what that's going to look like?
Sure. So 4 minus -2, and then 3 minus -1.
Okay. And what does that reduce to?
That's 6 over 4.
Yep. And that will reduce to 3 over 2. Okay. If the slope of DF is positive 3 over 2, what is the perpendicular slope to positive 3 over 2, or the negative reciprocal slope?
-2 over 3.
Perfect. Thank you, Logan. Okay, so I have my slope, -2 over 3. I'm going to put a magenta line around this. We're going to hold on to this. Okay, once you have slope, what are you going to solve for next? Once you have M. Okay, somebody just said an answer. I think you said midpoint. I think somebody said midpoint, but I lost it. So once you have your perpendicular slope here, oh, sorry guys, my screen's going a little bit nuts. Now you have to worry about the bisect part, cut into 2 equal portions. So whoever said midpoint, yes, that's correct. I'm gonna find the middle of DF. And then once I've done that, I'm gonna find the B value of my my y equals mx plus b. So midpoint is add the x's, divide by 2, add the y's, divide by 2. And this is on that formula sheet. So what's the middle of DF? You may not be able to see the points anymore. I'm going to add -1 plus 3. -1 plus 3. And I'm also going to add -2 plus 4. So what's the midpoint of DF?
One and one.
Okay, good. So you can use your calculators, do some mental math here. It's gonna be 1, 1. Thank you, Ian. I'm gonna put a magenta line around that because we're gonna need that here in a minute. I just wanna make sure that looks like approximately it makes sense. So 1, 1, does that look good? I'm gonna trust Ian's work there. That looks like it's about the middle. Okay, I have a point and I have slope. How do I find the B value of my line?
Plug that into the y equals mx plus b.
Thank you, Amaya. So I'm going to plug in, this is my x and y down here. So this is x and y. So 1 is y and x is 1. 1 equals -2/3. Remember to use the perpendicular slope. And how can I isolate for b? What's -2/3 times 1?
-2/3.
Fantastic. And then how do I isolate for b?
Bring it to the other side, which becomes 2/3.
Okay, so what's 1 plus 2/3? I think it's 5/3, or 1 and 2/3, or I guess 1.6 repeating, but I'm going to leave it as 5/3. I'm just going to double check. It would look like it would go through. Yep, if I had a perpendicular line here, it looks like it would go through somewhere just north of 1.5 there on my graph, so it's good. Okay, what is the final y equals mx plus b for the right bisector?
You don't have to build it. There's no one like it.
My y was, my slope is -2/3.
Why does he have to do this?
And my b value is 5/3. I realized, guys, this was a long time ago, and this is a process that we haven't really refreshed our memory of in a long time. So you will want to make sure you can do this in the review package. I will expect that you can do this on Friday on your culminating tasks that you're doing on Friday. And then on the exam day, on the Thursday, I may ask you, how did you solve this question? And you need to be able to tell me what you did. What's the thought process? What's the reason behind the negative reciprocal slope? So make sure you have very concise notes in your review package so that you can describe this to me when you need to. That's
Wait,
right,
Monsieur, I have a
bisector. Patrick.
Wait, is this package one that we're handing in on Friday, or are we doing another package?
These are different questions. I'm not doing any of the ones you're doing. You have a different package that you're doing.
I know
And you're okay, Patrick. It sounds like you're not clear on what's happening. So you have a review package that you need to complete by Thursday. On Friday, you will be doing a task on Zoom that I will be supervising. That's kind of in place of an exam, but you can think about it just like an exam. It will have questions from each of the different chapters that you'll be solving, which you will complete and submit on Friday. I will be doing over Zoom. And then on your exam day, you will sign up for a time slot, and I'm going to open up your package, and you're going to have to tell me how you solved some of these questions. So there'll be a conversation, and I may say, how did you solve this question when I asked you to determine the equation of a right bisector?
Yeah, but like the package that we're doing right now, that we're not handing that in or anything, right?
The thing that I'm doing right now on that right here, the screen share.
Yeah.
No, this
No,
is
no, no,
totally.
I know that's totally different. I'm talking about the one on Edge that I told us.
You will upload this by Thursday night, so I can see that you have this filled in your own handwriting. So this package does need to be done by Thursday night.
All right, okay.
So you guys should have, hopefully you've already started it. You got it last week.
And then is it a package, the one that we're like on Friday, is it like a package or like it's just like a task or what is it?
Well, you could think about it like an exam, but you'll be able to use the review package, that one I just showed you. So it's not necessarily open note, but you will be able to use the review package kind of like a memory sheet so that you can rely on the steps that you've completed in that package.
All right, and that thing on Friday, I can't lower our mark, right?
No, overall, the culminating task can't lower your mark.
All right, okay, thank you.
But it has a good chance of raising your mark. Okay, I'm going to move on to circle question. Your circle equation, you guys have this in that review package. Looks like this. I'm only going to ask you basic questions about circles like this. What would be the equation for this circle? This is a nice, easy one to jump in if I haven't heard your voice yet.
Miss Reed,
Yes, Matthew.
if we don't understand how to do one of these formulas, is there like, do you have like this booklet filled in with all the answers on your thing?
No. No, because that completely defeats the purpose, Matthew, of you completing it and writing your own steps if I'm just going to give you the solutions. So
Or like
you
just, like,
have
answers for some like just in case you don't know how to do something, do you have like the answers for it or no?
Oh, well, actually in this package, I'm hoping you guys have looked at this. If you go out to the very last page of this package, you have all of the actual answers. So you're going to know if you did it right, but I don't have the solutions. So I don't have them worked out, but you have all the answers right here.
Curious for the answers, yeah. That's all because I just
Yeah.
wanted to like check my work.
Yeah,
Thank
it's
you.
at the end of the package. Yeah, no problem. Okay. Who can solve this question? Determine the equation of that circle. No one remembers how to determine the equation of a circle. Joel, you raised your hand.
You would you have the radius, which is 7.
Yep.
Then you would square that, and that'd be 49.
Fantastic.
And you would write x squared plus y squared equals 49.
Thank you, Joel. Perfect. All you need for the circle is the radius. If the center is at 0, 0, which for this equation, I will always give you the circle centered at 0, 0. Thank you, Joel. That is the main things from Unit 1 that you will need to be able to do on Friday and then explain to me next week, Thursday. So substitution or elimination, basic formula use, midpoint distance, circle slope, equation of a right bisector. Any questions on any of those skills? Anything that's kind of lingering here from these questions that we just did? Okay, we're going to move on to the first half of Unit 2. So I will be doing refreshing your memory of vertex form today. And then on Thursday, we're going to do factoring, quadratic formula, and also some trigonometry review. So that is on factored form. Who remembers if we can determine if this table of values is linear, quadratic, or neither just by doing finite differences? How do we do this?
We find the differences between the y values.
Awesome. And I'm just gonna start at the bottom of the chart and work my way up so I don't lose anything. What's -10 subtract -4?
-6.
Awesome. -4 take away 2.
-2.
So let me say that
Or
again, AG.
-6.
Awesome, awesome. 2 take away 8.
6.
-6. And 8 take away 14.
-6.
Okay, so what is this data? Linear, quadratic, or neither?
Linear.
Fantastic. First differences will tell you if it's linear. This increases, well, actually, this decreases at a constant amount, -6, throughout that data chart. Thank you, AG. Here's your second chart. How do we know if this is linear, quadratic, or neither?
Where's me? Look at it.
AG already did one. Who else would like to do one?
You would have to find the differences. So if you start from the bottom, it would be 0 minus -3, which is 3.
Good.
And then the next one would be 1,
Perfect.
-1,
Okay.
and then -3.
Okay, so obviously not linear. So now what do I do, Ian?
You have to find the differences between those numbers now to see if it's quadratic.
Good. So what's 3 take away 1?
2. And then that would be 2, I think.
Yep,
And then
that's
that would be
correct.
2.
Awesome. So what's this data?
Quadratic.
Very good. If your second differences are constant, the data is quadratic. If this was not constant, if it went to -7, +15, then you would just say, therefore, the data is neither. It's not linear nor quadratic. It's something else that we haven't yet learned, or it's a complete random scatter plot. Okay, so just to be able to determine linear or quadratic. That was a very introduction to quadratics, and then we got into vertex form. Y equals A bracket x minus h close bracket squared plus k. What do the letters do to the parabola? What does the A do?
Tells you if it opens up or down.
Thank you. Very good, Kira. And what else does it do? Opens up or down? And what else does it do?
If it's stretched or compressed.
Very good. Okay, so let me just put some notes in here because you guys might want this for later. Kira, how do I know if it's opening up? What will the A value look like?
Positive.
Okay, and then by default, then negative A is down. And Logan, how do I know if it's stretched or compressed?
If it's, I'm pretty sure it was less than -1 or above it.
So if A is less than 1, so it's a fraction or decimal, so not negatives, just a fraction or decimal, what is that going to be? Stretched or compressed?
It would be stretched.
So if you took me and made me half of my height,
Wait,
you can.
no, compressed.
Good. Compressed. And then obviously the opposite is true. If it's greater than 1, it's stretched. Okay. Good. And then what about H? What happens here? If it stays x minus h, which way did it go? Or what happens to it?
It moves right.
Good. If it's a negative, it's moving right. So this is opposite to what we think. And if it's then switches to a positive, it's going to move left. So this is on the x-axis. Your h value moves it along the x-axis. And then k. What about k?
It moves up or down.
Okay, so if it's a plus k, where does it go?
Out.
Up. Good. On y-axis. And if it's a negative k, obviously we'll say down. It's the opposite. Okay, so the first thing we learned was how to describe a parabola. These are called transformation charts. So if you've been confused when I write that, like you need to be able to do transformation charts, this is the transformation chart. So it looks like this, and you just have to answer as much as you know based on the vertex form of the parabola. How do I know the vertex in this form? So what am I looking at in order to determine the vertex point here?
H and K.
Perfect. Oops. Just gonna write some notes in here so that we have very detailed notes for while you guys are doing your review package. So I'm gonna look at H and K. Kira, what's the vertex of this parabola?
-4 and 0.
Awesome. There is no K value. K has to be outside the bracket on the end. H has to be in brackets. So look at the equation very carefully. How can I tell the axis of symmetry?
By the H value.
Thank you, Kira. So what is the axis of symmetry for this parabola? Kira, why don't you keep working through this transformation chart with me?
-4.
Fantastic. And I'm going to write it as a whole equation because it is an actual line. It's just not a point. So make sure you have x equals. Kira, has this been stretched or compressed?
Compressed.
And by what factor?
1/3.
Fantastic. Now, how come you didn't say the negative? What's the negative going to do to this parabola?
If it opens up or down.
Fantastic, which in this case, I just wrote down. I already answered your question for you. And then domain and range. Kira, do you remember what we wrote for domain?
I know you use like the alligator crocodile thing.
Yeah. Anyone can you help Kira? What do we write for domain? Domain never changes.
EER or is it YER?
This is
EER?
X. Oh, this is X. So Matthew, you're on the right track. We're going to write squiggly brackets, X, E, R. And in English, what does that mean?
X is all real numbers.
Good. X is all real numbers. There's no limitation on the width of a parabola. So that you just always will write XER. How about range? How about my Y values? What's that going to look like? Who can jump in here?
YER is less than.
Okay, so Kira, you're thinking it's going to be less than or equal to, and what number?
Oh, would it be like greater than -4?
It's not -4. It's not my axis of symmetry. Who wants to help out Kira? This parabola is opening down. Yep, Ian, go ahead.
Less than and equal to 0, I'm pretty sure.
Where'd you get the 0 from?
Well, that's the Y.
Yes, that's the Y value of your vertex. So if the parabola is opening down, thank you, Ian. If it's opening down, it's going to be less than and equal to K. If it's opening up, it's going to be greater than. So these are the kind of notes you guys will want to make sure you have in your exam review package. Like you definitely want these reminder things here so that when you're working on Friday on the culminating project that I have for you, you're going to want to make sure that you know how to accurately fill this in. So put all of your little notes in your review package that I have for you. Make it a really detailed quote unquote memory sheet, memory package for yourself. So Kira did that one. Who can help me with this? Who wants to fill in this transformation chart? I want to hear a different voice.
Would it be 0 and -3?
The vertex point is 0, -3. Okay. Mia, you want to keep going?
Sure. Then it would be x equals 0.
Fantastic.
And then it'd be stretched by 2.
Fantastic.
It opens up because it's +2.
Fantastic.
And then it'd be like the squiggly brackets with X, E, R. That. And then the next one is the squiggly brackets with Y, E, R, then I don't know what that line is called, and then y to like it's negative is -3, so it's I don't know if that's like
Which way is the parabola
directions
opening?
like analogy.
Oh, so just tell me if is it greater than or less than?
Less than.
Well, this one's opening up.
No. Oh, greater than.
Good. Okay, good. Any questions on transformation charts? I'm going to stop this screen share for a second here. So you can do the axis of symmetry formula, which is this. You could find the midpoints of your x-intercepts. You could complete the square. The Math 10 teachers and I have all talked about the fact that you have to be able to demonstrate completing the square. This shows up in every level of grade 11 math next year. So you will be asked to complete the square. So if you don't want to pick multiple things to remember, choose this one. And there is a place on your exam review package to put those steps there. So that way you can use it as your memory aid. So complete the square. I am trying to get this into vertex form. I have kind of lengthy steps there on the side, but I'm hoping if we just look at vertex form, it will help us remember what we're doing. Who can walk me through this process?
Well, it's stretched because it's above 1.
Yep, but I want to turn this into vertex form. So how do I do that?
You're gonna want to you want to factor you want to multiply 2 times, find the common factor between 2 and 3?
You're not going to find a common factor between 2 and 3, but what you are going to do is take the a value out. So see how it's in front of the bracket there, Matthew?
Yeah.
You need to take this a value and divide it out. So I'm actually going to divide both of these by 2.
Oh, and then you're gonna get 6x and
there
x.
you go. There you go. So Matthew, let's just keep
Okay.
going with this together. Okay. So I've taken out the a value, right?
Yeah.
So I've done this, I've done this. So now you're going to look at the last term in the bracket.
Mm-hmm.
Okay. And you are going to divide it by 2 and square it. So what's
So you're
positive 6 divided by 2?
3,
And what's 3 squared?
9.
Awesome. Now what you're going to do is add and subtract that number behind the 6x in the bracket. So what will that look like?
Pardon me, what'd you say? You said
Add
and
and
subtract that number behind the last term in the bracket. So the last term would be 6x.
Yep. And now I'm going to put in this 9, right? Yep.
Yeah. And then you're gonna, 6. Yeah. And then, so the 9 cancels out because it's subtract 9. And then it's just gonna be x.
Well, actually, Matthew, we don't want to make the 9 cancel out. We're actually trying to create a perfect square trinomial in here. So you're going to keep the plus 9 in, but you need to move the negative 9 out.
Oh, no, out. Sorry. Yeah. You move it out to the -3. So it's gonna be -3 plus 9.
But it says to remember to multiply it by a. So what's a?
2. Oh, so -9 multiplied by 2 is -18.
Mm-hmm.
Oh, I see. Okay. And then 3.
Okay, now we need to simplify outside the bracket and factor the bracket. So what we just made was a perfect square trinomial. You guys know how to factor that. We did that in chapter 5. What does this bracket end up being factored? So square root of the first
15x.
Square root of the first term, sine of the middle, square root of the last term.
Ooh. Wait, so you square root the 9 and the x squared?
Mm-hmm.
So it's gonna be x squared, well, x squared squared x, and then it's gonna be 3
And what's the sign in the middle?
plus
Good. And then what's -18 take away 3 more?
positive 15, or sorry, positive 21.
It's actually gonna be -21. So where is my vertex now?
Your vertex is what's it called? Is it 3 and -21?
Yeah, -3 and -21.
Or -3 and 21? Yeah.
Yeah. Guys, we did complete the square a long time ago. This was chapter 4. So
so long ago. It's
I know. So if these steps are very, very unfamiliar to you, please put them in your review package. Make sure you have a detailed steps here of what your process is. So that way you can literally just look at that while you're working through the exam package on Friday, the culminating task, and you can make sure you're going to do that properly. One other voice here. We're going to complete the square one more time. Who can help me do this?
I guess I can go again.
Okay, Matthew, go ahead.
Okay, so you're gonna put negative 5x in bracket, yeah. And then you're going to and then you're gonna get negative 4. So you're gonna get x squared, and then you're gonna get negative 4x bracket plus 2, and then don't you want? So you're gonna want to get. Is it square the 4? No, you want to get positive 4, right?
You don't have to get positive 4. You just want to look at the last term in the bracket, divide it by 2, and square it. So what's half of negative 4?
Oh yeah, so it's 2, and then that squared is going to be 4.
Okay, good. All right, now we're going to add and subtract that in the bracket, and then you can take over here, Matthew. What will I do now that I have put this in here?
So you're going to bring the negative 4 outside of the bracket, but you're going to multiply by negative 5.
Good.
And you're going to bring it over beside positive 2.
Good. So what is negative 4 times negative 5?
Positive 20.
Positive 20. Fantastic. Now all I have to do is factor the bracket and simplify outside. Nice job, Matthew. So
you square x squared, which is x. And then you're going to have a negative sign, and 4 squared is 2.
Good. And what's 20 plus 2?
22.
Fantastic. Where's my vertex?
Your vertex is positive 2 and positive 22.
Nice job, Matthew. See how much easier that got just by doing it twice? You're like, oh yeah, I remember. It's amazing. Yeah, it's amazing. Good job, guys. So keep reviewing. It will all come back, I promise. I wanted to do one by the axis symmetry equation, but I would not really spend a lot of time with this equation because I will be asking you for sure to complete the square. And you can just about put money on the fact that on your quote unquote exam conversation day, I will ask you, how did you do this? So make sure you can complete the square. This is in standard form. So if you were going to do the axis symmetry equation, B is 12. So I'm going to put in negative 12. That's part of my formula. 2 times A. So I get negative 12 over 4. Or in this case, I get negative 3 as my axis of symmetry. And then the part that we were forgetting was now what? How do I find the y value of my vertex? Who remembers how I find the y value? Once you've done the axis of symmetry equation, how do you find the y value of your vertex?
You plug that in for x.
Thank you, Maya. So I'm going to plug in negative 3 for x. Somebody grab a calculator, or a few people, and just plug this all in one step. If I had 2 times negative 3 squared plus 12 times negative 3 minus 3, what's my y value?
I think it's negative 21.
Awesome. I also got negative 21. So then what's your vertex? How would I write this as a point?
Minus 3 and minus 21.
Thank you, AG. So if the question just says, like, what's the vertex? Like, this is a word problem, or if it's a multiple component type of question and you have to find the vertex, feel free to do axis of symmetry. But I would really strongly ask you guys to focus on complete the square instead. I know we've been on Zoom a long time together, so I'm just going to do one more skill set with you guys, and then I'll give you guys time to work. We had to learn how to write the equation of a parabola if we were given points. So the vertex or x-intercepts and a random other point on the parabola. You guys have 2 of these in your exam review package. If you don't remember how to do this, send me a message and I will just give you the YouTube link, because there is a video where I explained how to do this, whether you're given the vertex or the x-intercepts. So here's a question. Calculate the equation of the parabola if the vertex is at 6, -7, and it passes through 413. How do I come up with the standard form equation for this parabola given this kind of random information?
Isn't there a formula you have to plug those numbers into?
Yes, how do I know what formula and what formula might that be?
Gosh, I have no idea.
Who remembers how to do this type of question, or at least has a guess? I guess my first question is, can you start with standard form? Do I know
No.
A, B, or C? No. Okay, so I can't start with standard form. So what are your suggestions?
Vert? No.
Matthew, keep going. What did you just say?
I was gonna say vertex form.
Yes, look, I gave you the vertex. That is your visual clue that you are going to start with vertex form. What do I plug in
so
here?
That was right.
Yeah.
Pardon me?
What do I plug into this equation? What do I
So
know?
the vertex is at 6 and -7.
And what do
So
I plug those?
You're gonna put 6 at H and -7 at K.
Okay, now I actually still have a lot of variables left. I have X, Y, and A. So what
Yeah,
else
but
am I
you're
going to do
not-
here, guys?
You're not, so you have, so it passes through 4 and 13, but you're gonna have to solve, like, I
So
forget.
what is this? What am I plugging this in for?
You're plugging that in for if it's like A and X.
Well, is it A? Does it tell me if it's stretched or compressed or opening up or down?
No,
So is it possibly an X and a Y, Matthew?
yeah.
Yes. So I'm going to plug in 13 for Y and 4 for X. Now, the only variable I have left over is A, which is good. I need to know A for standard form. So let's use our algebra skills and let's solve this. What is 4 take away 6?
-2.
And what's -2 squared?
+4.
Good. How do I isolate for A? Look at this equation very carefully.
You're gonna want to multiply. I think I'm right. You want to multiply 4 by -7, and then you're gonna move that over to 13 and make it negative, or make it the opposite.
Actually,
sign.
this here, 4A, is not a like term with -7. So what do I do with this -7, Matthew?
You bring it over to the other side. So you just make
Yes.
that positive 13 plus 7.
Good.
And that's gonna be 20. So that's gonna be 20 equals A4. And then yeah.
And then how do I solve for A?
You're gonna want to divide 20 by 4.
So what's A?
It's gonna be 5.
5. Very good. Now, if I go back up here, Matthew said we're starting with vertex form. Right now, I have all of vertex form. I have A, I have H, and I have K. How do I get this into standard form?
Pardon me?
How do I get that into standard form? Right now, that's in vertex form.
So you have A, so you know it's gonna be it's positive, and it's gonna be stretched. So now you need.
So take a look. I just opened up the formulas that I'm going to give you guys. This is in your review package. How do you get into standard form? It doesn't matter if it's vertex form or factored form. How do I get into standard form?
Oh, you're gonna wait. We just did vertex, right? You're gonna
Yep.
FOIL.
Foil, exactly. So I'm going to foil and do BEDMAS. So this is kind of pulling in some other skills here. So if I write my x minus 6 twice, because that squared says multiply it to itself, I'm going to foil that bracket. Matthew, can you foil this for me?
Yeah, so what you're gonna do is x times x is gonna be x squared.
Good.
And then you're gonna do x times -6, which is -6x.
Good.
And then you're gonna do -6 times x, which is -6x.
Awesome.
And -6 times -6 is positive 36.
Perfect.
And what you're gonna do is you're gonna cancel out the middle, -6, subtract -6, and you're gonna be left with x squared plus 36, subtract 7.
Okay, so the -6 and -6 actually turns into -12x. But I will
Wait, is-
simplify that. Yeah, you're on the right track. I
Oh,
will
it's negative. Okay, yeah, I see. I'm
Yeah.
I'm gonna say.
That's okay. So BEDMAS says do the exponent. The exponent is FOIL. So I've done exponents. Now I'm looking for multiplication or division and then addition and subtraction. So Matthew, do you see any multiplication left to do? Anyone? I'm going to continue with BEDMAS now that I've done the FOIL. What am I going to do
You're gonna
next?
multiply everything by 5.
Perfect. I'm going to worry about that -7 at the very end. So I get 5x squared minus 60x plus 180, I believe, minus 7. Let me just check that really quickly.
And then you're gonna lower it whatever by 5x. You're gonna divide them, I think.
I don't have to divide, actually. All I have to do is put this the positive 180 and the -7 together. I just have to simplify. So this is going to be plus 173. And this is it. This is it in standard form. So then you're done. So it's kind of a long question. Anticipate seeing at least one of these on your exam review package on Friday, where I give you some information about the parabola. You're going to have to find information about it. For sure, you will always have to solve for the A value. Once you've done the A value, then you FOIL into standard form. This question down here, I just want to do one where you have your x-intercepts. If you have your x-intercepts, I want you guys to start with factored form, because R and S are your x-intercepts. So if I was looking at this parabola on the graph, I have one x-intercept at 0, so I'm just going to call this one R. I have this one at 6, so I'm just going to call this one S. And then if I plug them in, you can see again, I'm left with X, Y, and A. So I will always be solving for A. So I need to plug in something else for X and Y. In this case, I'm just going to grab 3, 9, which is a point on my graph, and I could solve for A. So whenever you're doing this process, please keep in mind you always need to solve for A. Once you have A, you will then FOIL into standard form. So if I have my vertex, start with vertex form. If I have my x-intercepts, start with factored form. So you might want to put a mental note of that in your review package. If you have the vertex, start with vertex form. If you have your x-intercepts, start with factored form. Once you have solved for your A value, then you are going to FOIL into standard form. So in this one, actually, it's quite a bit easier because of my values. I would just FOIL this into standard form.